Okay, good afternoon, everyone. Today, my name is Hassan Emanoon, and today we'll be presenting our Discrete Structures group project that's temporal and category-based price similarity and network analysis. Me and my group members, including Abdullah Amir and Muhammad Usman, will be presenting today. And what we're going to explore is that what something every Pakistani family is affected from. It's inflation. Now, most economists look at nationwide inflation rates, and we can't really determine what a single number is really affecting all the portions of the Pakistan. We determine this, our project determines this by checking the price inflation rate from the years 2023 till 2025 in major cities of Pakistan to determine whether this effect is actually mutual or there's a difference between the inflation rates in these cities. We took the CPI data from Pakistan Bureau of Statistics, and these included cities like Islamabad, Karachi, Lahore, Multan, and various other cities were also included. By the end of this analysis, we identified that which cities act as economic and trendsetters and which are the ones that follow. Please open the yes, it is executive summary is already open. So now what we determined was that there was a 9.9 at times coordination gap between the highly integrated utilities and transport sector, while the food sector was a bit fragmented. That we used temporal relationships with partial orders to determine network edges over these 3 years, and entropy based weighting systems were used, and we concluded that Sialkot and Gujranwala are major price setters. Like if there's a price variations, these cities were mostly involved. Now there were in analytical visualizations and similarity heat maps were also used, and all of these were used to determine can be used to determine whether that how we can control the inflation in certain cities. Like if you want to stabilize the food prices, you need to look in regions that are major food production zones of those area. Now I'll call Abdullah Amir to take over.
I'll be starting with the mathematical modeling that our project relied on. First of all, we normalized the rows and the columns of the headings so that we have so that our code reads them as unique items. Now we came across the data problem. The data problems. So when we looked at the raw data structures we received from Pakistan Bureau of Statistics website, we had 51 commodities organized into 7 categories. Each commodity had a different price for the 17 cities. So we came across a challenge. The price scaled wildly from 3,000 to 100. So if we compared these prices directly, the expensive items would completely dominate, and we'd be ignoring the cheaper items. So we came across the normalization solution. So we applied Z-score normalization for every item. For example, for wheat, we calculated the mean price across the 17 cities and the standard deviation. So the price minus the mean divided by the standard deviation gave us the normalized price. And as a result, every item, regardless of its natural price, was transformed to a distribution with mean 0 and standard deviation 1. This was very critical for our project because it ignored macro level inflation and which would normally dominate our analysis and it would obscure the real question of if the cities were actually coordinated or not. So with normalization, we isolate behavioral patterns from the macro effects. So next, cosine similarity. So next, in cosine similarity and relations. Cosine similarity basically is mathematically is the dot product of two normalized vectors divided by their magnitudes, product of their magnitudes. So if it basically implies if the cosine similarity is closer to 1, it implies that the two cities are similar, and if it's closer to 0, it implies that the two cities are orthogonal. Their pattern is orthogonal. We define a relation R on two cities. Two cities are related if their cosine similarity exceeded the threshold. So for our project, we analyzed 3 thresholds: 0.6, 0.7, and 0.8. The value 0.7 emerged as optimal. It was strict enough to filter the noise from our data, but it was also inclusive enough to capture genuine coordination. Next part, graph construction. And this relation induces a weighted undirected graph for each category and year combination. The cities were vertices V. Two cities had an edge if their similarity exceeded the threshold, and the edge weight equaled their similarity score. So we had a graph of y and c for every vector and every vector and edge. And as seen in the explanation of GYC is equal to V and EYC and W, and the explanation is seen as on the screen. So the next part, the threshold effects. Hassan? The report shows the table shows us the threshold effects. For food staples and grains, the table shows 8 edges with density 0.0588 and 9 components. And comparing this to utilities and transport with 47 edges and the density of 0.3456 and just 1 component. The contrast was profound, and the food networks fragmented into 9 separate components. Utilities remained as a single connected network. This is a fundamental insight that utilities were strong and they had robust coordination, and the food and the perishable items were weak, fragmented, and patterns were probably driven by regional agricultural supply. The next part, temporal relation and partial order. We define a temporal relation T between a network as seen in the report, and if a relation is partial order, the three required properties all hold: reflexivity, antisymmetry, and transitivity. Because T is reflexive, antisymmetric, and transitive, it would be a valid partial order. The hash diagram in the report show the structure visually for different categories. And in our data analysis, none of the categories were a valid partial order. So no hash diagram was connected. The next part, centrality measures. We computed four different centrality: degree centrality, closeness centrality, betweenness centrality, and eigenvector centrality. All these four measured different network roles. The city might be popular, it would imply high degree centrality, but not strategic. That would be betweenness centrality. It might be strategically located. That would be high betweenness, and with a few direct connection, that would be low degree. So we need all four centralities to get the complete picture of our analysis. Now, Mohammed Usman will continue with the code snippets showing how all of this was implemented in the code.
Now I will demonstrate our implementation pipeline. While Abdullah explained the theory, I will show the actual Python code that brings it to life. Our implementation uses four key libraries: NumPy for metrics operations, pandas for data manipulation, skitlearn for optimized cosine similarities, and networkx for graph algorithms, as you can see in the code as well. If Abdullah, please move the code down a bit. You can see that we extracted our files by dividing them into the years. Then we categorized them into 7 categories that were given in our project. Then what we did was that we made a data loading function in which PBS Excel files have inconsistent formatting. So we used extra metadata rows, line breakings in column names, or function read files with skip rows to skip metadata, clean column names, and handles file not find all the errors actually gracefully. And then moving down, we can see that we built a fixed mapping of all 51 items to their 7 categories based on the PBS classification system shown in the report as well as in the code. Items 1 to 8 map to food staple and grains. Item 41 to 47 map to utilities and transport. And further on, we divided the data more. For each month, we extract. If we can move down a bit into the linear yearly regression, we can see that for each month we extracted city prices for each category. We accumulated those prices across all available months, and at the end we compute within category yearly means. The report also shows this at the stage 2 of pre-processing pipeline. We handle missing months gracefully, and if June 2023 was missing, we average the other months available for that year, and June 2025 was also missing in our data, so we हमने उसको भी सही से handle कर लिया था. Then moving on, we can see that we take the yearly price matrix 17 cities by varying items for each category and normalizing per item. The report and normalization validation section confirms that z-score distributions achieve mean approximately 0 and standard deviation approximately 1, which we apply in our code with the precision critical for valid cosine similarity calculation. Okay? And if we move on, we use skitlearn optimized. If you can show the compute similarity matrices code, please. Yep, and we can see from here that we use skitlearn's optimized cosine similarity function in which we input normalized matrix 17 cities and all that, and we got the output of 17x17 similarity matrix. Each entry is the cosine similarity between city I and city J. Moving down, we can see from the function of building graphs with threshold, and where the core graph construction logic happens for each category and year. We create a network X graph with 17 city nodes and iterate through all pairs of cities in the similarity matrix and edges where similarity exceeds by the threshold. Then moving on, we can see the compute centrality measure function where network X provides built-in functions for all 4 centralities. We compute degree, closeness, betweenness, and eigenvector centrality here. We include error handling for eigenvector centrality as well, because disconnected graphs can cause convergence failures. Okay. Then moving on, we have the compute entropy with entropy weights for centrality function. We can see that we don't use arbitrary weights. Instead, we calculate Shannon entropy for each metric based on formulas shown in the report. For each centrality measure, we normalize to create a probability distribution computing entropy. The function is given in the function, this function basically. And then moving on, we can see the weighted centrality and computing all overall influence functions, in which we can see that we compute the degrees, closeness, betweenness, eigenvector. This combines all 4 metrics using entropy weighted importance. Then we aggregate across categories using category importance. Now let me give it back to Abdullah to show the visualizations and what all these numbers actually mean.
So in our project, we use heat maps, we use network graphs. We plotted these we plotted these threshold sensitivity graphs through the Python code, and moreover, we also generated bar graphs that were all used together along with these radar charts to analyze and to give us a verdict of what the data we read from the Pakistan Bureau of Statistics implied. So now Hassan would now proceed with the implication of the data, and then Usman would follow him for the conclusion of our project.
Now, from our analysis, it can be determined from a centrality analysis. It reveals that each city has two key roles. Some are hubs and the other are bridges. For example, Sialkot and Gujranwala are consistently ranked as primary hubs with the highest degree and closeness. These reflecting their roles as major industrial and production zones. As we all know, Sialkot is a major sport goods manufacturer, and yes, and the other bridge would be like, for example, it can be seen from, it was deduced from these results that Peshawar only has moderate degree of what do you say? Moderate degree of betweenness, and making it a bridge as it channels price transmission, making it a bridge to other cities like local cities of those northern areas. Now, Abdullah, can you move on to weighted scheme, sensitivity? Yes. With these weighted graphs, we compared two methods. One was equal matrix, and the other one was by entropy based scheme. And this was used to emphasize these emphasize that. These emphasizes that these are some major essential categories, as they enable us to rank from which category of items is most stable and which is highly volatile. As entropy based scheme told us that there was strong betweenness between food and utilities. However, their core hierarchy was same, but due to our weighting choices, it could be deduced that clothing was a little bit more towards the volatile side. Now, network thresholds was used with threshold sensitivity graphs and network evolution graphs, and like it's their implication to conclude, which Usman would be continuing for.
I would like to say that we successfully use discrete structures to analyze real CPI data from Pakistan and show how mathematical tools can uncover patterns hidden inside economic systems. After normalizing the data to remove the impact of extreme inflation, we built similarity networks for 7 major categories across 3 years and confirmed that their temporal relations form valid partial orders. Using centrality measures and entropy-based rankings, we identified key structural roles in the network. Sialkot and Gujranwala emerged as the strongest hubs, while Peshawar acted as a critical bridge. Overall, the analysis revealed a 9.9x coordination gap between infrastructure and agriculture, highlighting how unevenly different sectors respond across cities. This project isn't just code; it includes a full modular Python pipeline and over 40 high-quality visualizations easy to interpret. Still, our work faces some limitations, such as missing PBS Excel files and short 3-year window, and fact that our networks only cover Pakistani cities with a fixed similarity thresholds. Looking ahead, the report proposes several extensions, comparing Pakistan's CPI network with neighboring countries, simulating how price shocks propagate across the network, integrating CPI patterns with physical supply chains, and even building a real-time dashboard that updates monthly for the data. In conclusion, the project shows that the discrete mathematics isn't abstract. It's a powerful lens to understand real economic behavior. By treating prices as a network system rather than isolated numbers, we reveal a complex landscape of hubs, bridges, and isolated regions that shape Pakistan's urban economy. The complete code visualization and presentations are all also included in our submission, so you can see that. And thank you for your time for being with us. This was our project.